we'll ultimately start with Susan. So the objective for the data jamboree, just to kind of give us some perspective, is to solve the same problem with 3 different coding languages. And I think this is a very valuable thing to look through, where you can kind of compare the different approaches, see the pros and cons, and even sometimes it can give us a better understanding of the problem. You know, if someone tries to address it with a hammer, someone else uses a drill, someone else uses a different tool, and you can kind of get a better sense of what exactly the goal is. So based on Susan's availability, maybe we can make a slight change, and I can start with you. And what we had originally scheduled was about 5 minutes just to introduce web scraping. So what I can try to do here is give a impromptu couple minutes on that, and then maybe Susan, I'll give you another minute or 2 to add into that, and then get into your scheduled remarks. Does that sound okay?
That sounds fine. Or if you want, I can probably do the intro to web scraping bit pretty easily. So
I'm gonna, you know what? I'm gonna spin it right to you then, Susan. So what we have here is Susan will get us started. Let me give her a little bit more formal introduction. So this is Susan VanderPlas. She's an associate professor in statistics at the University of Nebraska-Lincoln. Susan considers herself primarily an R user, but does teach in both R and Python, and has written an open textbook teaching data science skills in both languages. So Susan will get us started, and she will be looking at the problem of scraping data for Olympic athletes using Python. So at this point, I will stop, and Susan, you can take it away.
all right, I'm just going to check. Can everybody see my screen with the Olympics page up? Is that working?
I see it.
Okay, awesome. I've had problems with that in the past. Okay, so we started out, I think, with the general list of athletes, and the goal was to scrape 3 different team sports and 3 individual sports, and get the athlete names. And then there were a couple of options, but the goal was to get eventually to the athletes' birthdays, and examine the hypothesis that for team sports, especially, that you're more likely to have a birthday earlier in the year based on the rules for things like hockey, that January 1st is when you are eligible to move up to the next age bracket. And so people born early in the year would be bigger and get more investment all through their sporting careers up until they become, Olympians, right? So we were supposed to be looking at that. So this initial thing is supposed to examine kind of how one would identify the bits and pieces of a web page that need to be scraped. And speaking only for myself, my favorite way to do this is to use the inspect feature. So you can actually just right click on a item on a web page, and most browsers, I'm using Chromium here, but most browsers will take you to the specific HTML element that you right clicked on. And generally speaking, that works pretty well. So here you can see that I've got a table. I've got rows and then cells within that table. Inside those,
sorry for
say what?
interruption. Excuse me. Could you zoom in a little bit? Our side is kind of a little small.
Is that helpful?
Yeah, definitely.
Okay. All right. So I'm actually going to zoom out on the web page itself because it's more useful, I think, just to be able to see the bits that are highlighted.
Yep.
The text is somewhat beside the point here.
Thank you.
Yeah. Sorry, I'm working on big monitors, so I kind of forget that that's an issue. All right. So the important thing to look at here, our goal is to get the athlete's name. And depending on how you approach the problem, either to get the address for the Olympic athlete page or to take the athlete's name and go for the Wikipedia page that represents that athlete. in either case, we want to get something from this element, right? And so we either want the href portion of this, which is the link, right? Or we want the competitor name. And so you can see the last name with the lowercase first name or just the short name. And so you would potentially look for an element that has the class competitor long name. These other things are formatting related and we don't necessarily need to care about that. But if you start looking for something with a class that has this in it, that will give you the name. Alternately, if you look for something that has the class competitor container and get the href element out of that, that gives you the data that you want. In practice, I think I've used both R and Python for web scraping, and both of them have functions that will let you read in a whole table. But it can be helpful. Sometimes those functions do not actually preserve the links and some of the elements of the table. And so it can be helpful to know exactly what to look for. And there's really no substitute for looking at the HTML. The other intricacies of this problem I actually will cover as I go through my Python stuff. And so I think that's probably enough of what we're looking for in HTML as we go through this. The next thing that I'd say is if we actually click on a link, you can do the same sort of thing. We want the birthday, right? So let's right click on the birthday. We could either get this date time element here, or we can get the plain text rendering of the birthday and then convert it. So it becomes an interesting challenge. You'll notice this, if you looked at the web page, you'd think that this was maybe a table, just because everything's laid out very nicely in 2 columns. In the HTML, it's not actually a table. It's a set of flexible columns, and each column has a bold element that's the variable name and a generally unspecified element. So, you know, if we look at the next one, the age, right? There's no bracketed thing that says this is what this is. So we've just got plain text. It's not within a node. That makes it a little bit harder to read this data in. At the individual level, if you go to Wikipedia, we can see if this person's Wikipedia page comes up. Okay, so you would have to figure out how to map the first and last name to the Wikipedia page when she's got 2 last names on the Olympic page. But then you could also go in and get and inspect this personal information over here, right? And so you maybe look for info box of data and then get the first, sorry, didn't realize that I was holding on the control key there, but you could look for class B-Day and pull that out that way, right? So that's the basic overview of how we would pull this information out of web pages. The art of web scraping really is figuring out how to tell the computer which bits and pieces of a web page to pull out. Everything else is not so bad. All right. So with that, I guess I will transition into solving this task with Python. And I'll give the general caveat that I'm still a Python learner, and most of that learning involves going, okay, here's how I would do this in R, what's the equivalent in Python? And then getting frustrated because Python doesn't quite work like R in every respect. Which is normal, I think, for switching languages, but in some cases, Python's got very shiny, fancy tools. Web scraping is one of those things that tends to be a little bit better supported, I think, in Python. But then Python is not R when it comes to working with data. And so I found myself frustrated by that. All right, so let's go ahead and start with, if you want, I wrote up a full like narrative version of this as I was figuring out how to solve the problem. And so that QR code will take you to the narrative version if you want to snap a picture of that. But all right, so my basic game plan when I started doing this was, okay, I've got URLs for each sports athlete table. Let's just try to scrape that directly. A lot of modern web pages actually involve data being injected by JavaScript after you initially load the URL. So the data is not there and then it appears. And if you look at how this loads, you can actually see that the table is initially empty and then gets populated. So I had a suspicion that that might be a problem. So if the data wasn't originally there, I was planning to use the Selenium WebDriver bindings in Python. The same strategy that I would have used in R, to be honest. I wanted to then create a single table with the athlete link set for each sport, plus whether the sport was individual or team and what sport it was. And then I was going to use the info from the athlete table to get the birthdays. My general philosophy is if you can get all of the data from the same website, that's better than trying to combine information across multiple different websites, because that tends to, in my experience, go badly. So I figured I'd start out with the Olympics website and then move to Wikipedia if I couldn't get the Olympics website to work. Just because then you've got data that's coming from a hopefully single database. I figured that the athletes probably had to submit their birthdays when they registered for the Olympics, however that happens. And that might be more likely to be correct than anything that was compiled by randos on the internet, as much as I love Wikipedia. So I started out by trying to scrape this table of athletes, and the first problem that I encountered was that Python's default user agent for any URL handling is blocked. And so I had to first set the user agent to look like a normal browser. And so what this involved was so I tried to use Google, right? And so that's how I tested it. But then I just set my user agent to say that I was on Windows, which I am not, and using Firefox. And once I did that, everything worked. I could read the page, but I couldn't actually see any of the table elements on the page because they're being injected later with JavaScript. So my handy setting the user agent thing ended up not mattering because the very next step was to use Selenium. The hardest part of that actually was if we go and pick out, I think one of our disciplines was artistic gymnastics. And so if you go to that page, you'll notice that you get by default a pretty long table, and Selenium will not. So Selenium allows you to, like, it pops up a browser window, which is great. And then it allows you to click on elements just as if you were browsing the web. So I kind of think of it as using a remote control to navigate the web. But the problem I kept having was that the code that I had to scroll down, because it won't let you click on a button that's not visible, the code to scroll down didn't work as well as I wanted it to. So what I needed it to do was to scroll down so that I could click this next button. And so I had to implement some pretty hefty error handling because the scrolling just didn't seem to work reliably. And I've had similar problems when I've done things like that in R. I decided to, after poking around this first page, if you click the next button 3 times, then it becomes disabled. And so when you get to the last page, there's just no next button. So what I decided to do was, rather than figure out how many pages there are, which you could do by, looking for the page X out of Y information, I decided just to use a while loop and break when that button was no longer enabled. So another thing that I generally try to do is to save the data incrementally so that you don't have to rescrape. And that is in part to be kind to the web server itself, making repeated requests to a web server just because you are tweaking your code is not generally considered good practice. So I would customize, like write a function and customize that function for whatever sport that I was testing things out on. And then I would try it on a whole sport, save the whole table, and then move on to the next sport, and try to make sure that the function actually worked. But I wouldn't like go rescrape things unless the function changed a ton and the data that I saved would have changed. So that's one thing that I generally try really hard to do when I'm web scraping, but don't always manage, because sometimes you realize, oh shoot, I scraped everything and I didn't get this field that I needed. All right, so comparing what I would normally have probably done in R to Python, the beautiful soup package in Python is amazing. And it has this function called soup strainer that allows you, instead of like parsing the entire HTML page, it lets you identify a specific set of things that you care about, pass that into the soup strainer function. So I said, I want to keep links that have the class competitor container. And this soup strainer thing just keeps those links. And so at the end, I get a pretty list of all of the href elements of those links, which is basically everything that I need to keep. Just the link for each athlete as we go down the page. So that was one thing that I found that was really nice in Python. All right, so next I decided to write the function to take a sport and get all of the athletes from that sport. So for each page, it would read the table and append that to a growing list of all of the athletes. And then at the end of the loop, if the next button is enabled, scroll down and click that button. I used a Lambda function to go through a series of URLs and assemble all of the data. And then I used dataframe.explode, which is equivalent to R's, or I guess Tidier's unnest function, but I think explode has a much cooler name, to move from one sport per line to one athlete per line. And then I just pasted on, you get a stub of a URL. So just the like /athlete/ whatever at the end. So you have to add on the olympics.com/en part of the URL to get a full URL that you can then visit in the next step. All right. So the table of athlete set of data that I have at this point, after exploding everything and making the URL a complete URL, looks something like this. So I've got, whether it's a team or an individual sport, the sport name in terms of common parlance, which is admittedly USA centric, the URL sport name, which is a bit different, and then the link to the athlete's page. So I don't even have like an athlete name in here, though it wouldn't be that hard, I think, to pull out the athlete name from the URL and use that. And in fact, that might actually work to get it into a form where I could take this athlete name and go find their Wikipedia page. But that's not what I did. Instead, I went and scraped each athlete's data from the Olympics website. So the athlete data is in an HTML object with the person info ID. So if we go over here and click on somebody's stuff, one person's page, we can see this person info section. It's got a column that has a picture, a column that has all of the information, and then within that column, there's a row that has another two rows, and then a second row, right, that has two different columns. Okay, so if you've ever messed with Shiny, it's very much set up so that you organize your apps like this. But this is not an easy thing to figure out how to scrape, mostly because this information is not actually a table. So my strategy was to get you can get the text from each element in the line pretty easily. And so you can get the text of this div element that has both the name and the value. But you can also separately get anything that's bolded. And so what I did was to get the bolded stuff and then the full text of the line and find replace to substitute out to get the value separately. And then I did a little bit of processing to get a pandas data frame, and each athlete's information was returned as a single row data frame. All right. So if we use Skimmer to look at this, or sorry, Skimpy, or Skimpy, which is, a much more fun name in my opinion, than the R equivalent. We can see that there's a fair bit of missing information for things like height or birth country or place of residence, but everybody has a birthday. And that information is in every single web page. So for our minimal purposes, this approach worked pretty well. The data looks like this by default. I picked a few columns because I actually kept all of the information from that person table or person info layout. But we've got minimal age, birth country, date of birth, name. The IDs don't match here because the IDs are actually for the sport. So that I probably could have gotten rid of that, but it's fine. It's not something that's going to trip us up later, so it's okay. All right. So data cleaning wise, I created a date variable that, wasn't a string. And this is where I started missing R and lubridate pretty heavily because I had to write my own decimal date function. Life is hard. Actually, I copied this off of somewhere on Stack Overflow, and the link is in the narrative. I certainly didn't come up with this myself. But yeah, there wasn't a decimal date function, and that was annoying to me. But I started out by just plotting if we look at the sport type as a team sport versus an individual sport. And I pretty quickly got annoyed by the fact that there are many more individual athletes than there are team-based athletes. And so I figured out how to normalize things by group so that we could accurately compare across groups. And once you do that, there's of course some variation, but I'm not super convinced that there's any real differences there. It just kind of looks like normal variation, but we can actually go into this and look at by sport. And for this, because there are 6 different sports, I figured I'd show you the code first, and then the plot. And so by sport, it seems like, yeah.
I'm sorry. Are you sharing your screen now? Is the hope that we can see what you're looking at? So
I thought I was. Did it stop sharing somehow? I can reshare.
I was seeing it.
Okay. All right. I was gonna say I have reveal slides here, so hopefully, can you see the plot?
yes, thank you.
Okay. All right. Sorry if that went wonky, but I'm gonna point the finger at Zoom for that one. Anyway, so I have the birthday distribution by sport, And, track and field seems to be way more uniform than a lot of other sports, but I don't see any strong evidence for the idea that you have a serious advantage if you're born in January. And I suspect that that's because I imagine that this happens differently in different countries. So even in different sporting organizations, as to whether they go by the school year or by the calendar year. And then, of course, different countries handle age differently as well. And so I suspect that we're just kind of averaging across a bunch of different conventions for how sporting and age categories work going through childhood is my current hypothesis after kind of playing with this data for a little bit. Right. So, but that's kind of where I stopped. I thought about trying to continue on and see if there were advantages based on like, are you more likely to get a gold medal? But it seemed like the data would be pretty sparse at that point. And so I kind of just stopped, having spent already a bit too much time on this, because to get all of the athlete data and not like overload the server, I was trying to be nice. I ended up implementing like a pause between each athlete's like pulling a new athlete's page. And that as a result, I basically like set it and let it run and came back the next morning and found out the code didn't work and then did that again the next day when it did. So web scraping and aggregating, 4,000 rows or something like that can actually take a significant amount of time if you're trying not to be a jerk. And having spent a little bit too much time on that, I decided not to continue delving into it after finding very few significant looking things. So that's where I stopped.
Susan, thank you. So I also, just personally, as someone who's tried to address this problem, I like how you bring in the frustrations. I think that's a big part of this, and those are the big learning opportunities. So what I would like to do for time is transition to Brandon, and then we'll have time for Q&A at the end for all the panelists. So I see that Brandon Carter is available. So I'll give a very brief introduction, and then I'll allow Brandon an opportunity to walk through. So Brandon Carter is a PhD candidate at the University of Texas, Austin, and he's just weeks away from his defense. So let me be one of the first to issue an early congratulations. And on top of that, he's a Julia enthusiast and is excited to see Julia usage continue to grow in the stats machine learning community. So Brandon, when you're ready, please continue. Thank you.
Okay, thank you, Jackson. Full disclosure, I've web scraped before, but this is my first time in Julia. I really like Julia to roll your own, which is needed quite often in grad school when you're developing methods for your dissertation. It writes like Python, but runs like C is the common refrain for Julia. Honestly, Python is the superior language for web scraping. The tools are just more developed. So in Julia, like Susan already mentioned, we have two types of websites that we commonly deal with. Static websites are really easy because it's just the HTML. There's no JavaScript running underneath that's pulling data and then rendering the HTML on the fly. So then we also need a WebDriver to interact with a website through code. And this WebDriver application in Julia is also built on Selenium. So if you're using the WebDriver package from Python, it's going to feel incredibly similar. There is another option, Blink, in Julia. I wasn't able to get the website to load in Blink, and so I didn't spend too much time on it. Also, you're passing JavaScript code directly through Blink. And so instead of having some sort of wrapper function that's easier to work with, you have to be kind of proficient at JavaScript. So if you are, maybe Blink will be easier, but for someone like me who doesn't really know JavaScript, I didn't want to have to mess with that either. And then the other packages that we'll be using, HTTP is to scrape a static website to parse the HTML. Gumbo takes the HTML and makes it into an easy to work with tree structure that we can easily subset to find different elements. And then Cascadia is pretty limited but powerful. We can use CSS selectors, which Susan already highlighted how we can find those from inspecting a web page in order to pull the elements that we're interested in. And that really is the meat of any web scraping, is just being able to identify what particular HTML element and then making sure you're getting the unique ones that you want. So I'm using a Chrome driver. If you wanted to do this yourself, you need to install some sort of WebDriver application and then use this WebDriver package, remote WebDriver. I'll launch it. I'm sure there's a way to fully automate this, but I just started Chrome driver in the terminal. Once you do that, it says which port the Chrome driver is connected to. And so you need to change that for whatever port is listed. And then you can start your session, which I already have done here on the right. So there are some easy functions in order to navigate. So we're just using the code to interact with our WebDriver so we can navigate to this page. First thing that we'll need to do is click this cookies button. And so we're finding the element from the WebDriver application with this element function. So here I'm using a CSS selector. And so this cookies button has the ID OneTrust accept BTN handler. So I'm finding the button on the web page, and then I can click the button. So if we just do the code, sweet, click the accept cookies. So now we have the page with all of the athletes. So we're going to be switching to Gumbo. This is the only function that we use for Gumbo. It's just the parse HTML. And so from WebDriver, we're sourcing the HTML from the session. Now the JavaScript has already run. So it should be the HTML data with all of the athlete info. And so then we get the HTML in this nice hierarchy. So if we look at the field names, we have the doc type and root. Root is going to be the HTML data that we want to access. And then in standard HTML format, you have the header and then the body. So the body is generally where that information lies that we're interested in, but you could be interested in getting the head, which would be that first element of the root instead. So we're just pulling the body. So again, we can look at the different elements of the body. So for the Gumbo package, it's really nice to work with. For each HTML element, it has these different attributes. So you have the children, which would be all the descendants in the tree, or the parents, like the nodes higher up in the tree. And then the particular attributes of that HTML element. So when Susan was talking about getting the href, that would be an attribute of the element that we would be able to extract by finding that particular attribute. So we could look at the attributes of the body. So it has this particular class, this particular style. So just as a dictionary, and so we can extract those as we would like, or we can subset based off of the tree structure. So if you know that a particular element follows a specific pattern throughout an HTML document, you can subset using that particular pattern based off of the tree structure of the HTML. But much easier to do is to use these CSS selectors. So now we're switching to the Cascadia package, which only allows you to use CSS selectors, which are generally pretty easy to work with. You either have the class, which is followed or preceded by a dot. We use the ID up above, which has the hashtag. And then a particular element isn't preceded by anything. And so here we have a span that is of class, competitor, long name. And we could append those additional classes, but this was sufficient enough to find that unique element. And so we're just using the built-in each match function from Julia, which normally uses regular expressions to find matches in a text, but if we wrap it with this selector function from Cascadia, we can pass this CSS selector to find all of the HTML elements that have been parsed from Gumbo that match with this CSS selector. So each match will always return a vector. So if we want to check that our match is unique, like if we're only looking for one specific element on the page, we still can just use the length of the matches to find that particular match that we're interested, or find that it was unique if we just have length 1. So here we only have the first 50 athletes on the page, first page. So we got 50 matches, which is what we want. Then we also have this nice function to get the text of the HTML element, just node text. So we get the first name of that first, or get the name of the first match by just extracting the text from that span element. So we can do that for all 50 athletes just by looping through all of the matches. Pretty simple. So now we need to click to the next page, which requires us to navigate to the next button. Navigating is pretty difficult with the WebDriver, as Susan already mentioned. So here I just clicked that move to next button, and it didn't move all the way down. So I needed to click it a couple times. And so in the function that I write later on, I'll just put it in a for loop and do an arbitrary number to make sure that it really navigates to that next button. I found when I wrote the function that moving to the next button, which is this single arrow here on the right, didn't work super well. And so instead I found the box around this pagination right, around all of these elements, and moving to that box worked a lot better than moving to the specific button. So if I just scroll up on this page again, so I found this different division, the pagination right. And if I move to the box, that worked a lot better and brought that button into the view of the WebDriver so that we could click it. So if we click the next button, then we get the next page of athletes. So those are all the elements that we're essentially going to put together in order to scrape all of the athlete names. And so when we put it together, right now we were just working interactively. Something really important when you're creating a function is that you need to give time for the WebDriver to actually load the data before you execute the next command. So we just use system sleep to pause the code for a little bit before that next command is executed, gives time for the HTML to be rendered. Otherwise, the data that we're looking for may not have been loaded, and we'll get an error. Also, just wrapping things in a try-catch statement can be pretty nice in case it does throw an error. So for the first time, we need to click the cookies button. But now that I've already loaded the web page, I don't need to click the cookies button again. So if I try and click a button that isn't there, it's going to throw an error. And I don't want that to mess up the code. So just throw it in a try-catch statement. And with this catch, you can catch the error code and then do things with it in the second part of the statement, but didn't see a need to do that just for the purposes of this demo. Oh, and then here is the for loop to really make sure that I'm moving to the box. So I thought 3 was sufficient, or seemed to be sufficient. And then everything else we have talked about. Susan did share her code, so I thought a method of checking of whether the next button was activated was pretty nifty. And so we have this is enabled next button from the WebDriver package to check. We don't want that to be the condition of our for loop or while loop, because we wouldn't be able to scrape the last page, because once we navigate to the last page, then the next button would be disabled. So I think it's kind of fun to watch this in action across the different sports. So we have 6 different sports that we wanted to compare the birth months of the athletes for. And so we're just going to loop through those sports and use this get athletes names package to get all the athletes for those 6 different sports. So if we run this, it'll navigate to the athlete page. It takes a little bit to load the first one. And we may need to help it scroll down to the next button. So yeah, so this first page takes a little bit to load, but then it will start scrolling down. To that bottom page. So we're having that system sleep, but then it clicks the elements and is able to pull all of the athletes. And so I can interrupt this because we don't need to, see all of them. But then I put the athlete name. So I just pulled the athlete names instead of the href, just went to that Wikipedia pages for the athletes. And so saved the athlete name in the way that it was formatted from the Olympics page, created a column for the sport. And then I know that I'm going to need to reformat the name to access the Wikipedia page because the Wikipedia page has a different format for the website of the athlete name. And then also creating a column beforehand to save the birth month when I'm going through the Wikipedia page. And then going back to the WebDriver, we can delete our session with this delete function. And so that will close it out. So now we'll move back to, this is on the GitHub that's shared on the Data Symposium website. So it should be accessible to everyone. So first, we have all the athlete names in our data frame, but we need to reformat them into the way that the Wikipedia page tag looks for the different athletes. So right now we have the family name in all caps and then the given name in title case. So the easiest way I thought was to find the first space that is followed by a word in title case. So whenever using regular expressions, I really like this website, regxr.com. I think it's really easy to use, pretty nifty, just explains what the regular expression is and how it's functioning. This is kind of my go-to spot if I'm trying to develop a regular expression. So you can paste in your text that you're interested in. So right here, I have family name and given name and title case. And so I created a regular expression that's looking ahead for a title case word. So a single capital letter followed by any number of lowercase letters, and that is preceded by a white space. So this regular expression is going to find all of the white spaces that are followed by a title case word. But if we go back to our code, when we're using this split function to split a string based on a regular expression, we're setting the limit to 2 so that the length of the output from the split is only a vector of length 2. So what that does is just find the first split instead of splitting on all of the spaces that are followed by a title case word. And then we're going to reorder so that we have the given name first, and then put which is already in title case, paste it together with the family name, which we want to convert to title case. And then if there are any spaces, because some people have multiple given names or multiple family names, replace those with underscores for the appropriate Wikipedia format. So this actually misses quite a few of athletes. So Susan's method of just using the Olympics database is a lot more thorough. And so our results are going to look quite different because a lot of the athlete names aren't covered. So for example, we have Liu Yang, the gymnast, and Wikipedia has another additional tag of underscore gymnast in parentheses for his website or webpage. Versus Liu Yang, the taikonaut, or Liu Yang, the violinist. So we missed like probably 1,000 athletes, but we got quite a fair number of them. So just for the purpose of demonstrating the web scraping. And then also there were some athletes that had hyphens in their name that wasn't represented in the Olympics webpage, or special characters. Wasn't sure if those got caught either, like an umlaut or a grave accent over a vowel. But so the base URL is just going to be the Wikipedia wiki, and then we have the reformatted name, which captures quite a few of the athletes, so does pretty well. So now the difference, we're going to use HTTP to get the static URL, since there isn't anything that needs to be compiled. And then this HTML, the HTTP is going to be in binary, so we need to wrap it with the string to convert it to string text that can then be parsed by the Gumbo package. So here, to get the birth months, there actually turned out to be a hidden span. So it's not visible on the Wikipedia page for the athlete, but it's called B-Day. And that particular format is in this year dash month dash day format, which is pretty easy to work with. I don't have to convert it to a date time. I can just use a regular expression to extract these, the month in the middle. So that's what this regular expression does. It looks for dash followed by 2 digits, and then, or preceded, 2 digits preceded by a dash and followed by a dash. So that's going to capture just the 2 digits between the dashes, and then we can convert it to an integer instead of a string. Nice and easy, pretty quick, simple solution. And again, we're throwing this in a try catch statement in order, in case the website doesn't load, or it doesn't exist, or the birth doesn't exist. That way it doesn't throw an error that messes up our function when we put this in a for loop. So because we populated month with 0 previously, any athletes that we weren't able to find a month, we can just filter out. And then, as Susan mentioned, it's good to save our intermediate results, since it takes quite a bit of time to get all of the websites scraped. Because we don't have to use a WebDriver, the HTTP is a little bit faster than the WebDriver, but still takes quite a bit of time to go through the 4,000 different athletes. So it probably took 20 minutes to get all of the athletes using the static web pages. So pretty quick, especially when you're just trying to scrape a very specific element. Should also note that I'm not aware of a Julia function yet that can scrape tables efficiently. Looking at the documentation, I didn't dig super closely to Cascadia, but that's also another drawback, is if you want to scrape all of the data from a table, there are these functions in R and in Python that do that pretty quickly. Maybe there's one in Julia, but I didn't find it. And we didn't need it necessarily for the birthdays, but there are commonly we want to scrape data from tables. And so it'd be a little bit more involved if you're trying to get the entire table from Julia into a table format or a data frame into Julia. So now moving on to the analysis. I'll let you look at that on your own time if you're interested, how I formed the frequency tables, nothing too fancy there. But just looking at the output. So again, output looks kind of different because I wasn't able to get all of the different athletes, nor took the time to make sure that I was getting the specific Wikipedia pages for those athletes whose name didn't follow the Wikipedia format. And so it looks like there are more athletes born in January for individual sports, and then July for team sports. I wouldn't read too closely at this comparison. Maybe a fun fact to share at a dinner party, but not one that I would bet any money on. For individual sports, maybe, I don't know, just hypothesis that it's more consistent for individual sports to have the age cutoff be at the start of the year. So people born in January would be the oldest. July felt like a weird cutoff. It doesn't line with the school year per se. So it may just be a fluke of also athletes not having the complete set for the sports of Olympic athletes. But that is all for the web scraping in Julia.
All right, Brandon, thank you. So what I'd like to do for time is just move to our last speaker, and then we'll have some time for Q&A at the end. So just a quick reminder, there's a Q&A box, and you're welcome to type your questions there. And I believe the panelists as well can try to answer those questions in writing. So our last presentation, so we've seen Python, we've seen Julia, and now it'll be R with Kelly Bodwin. And Kelly is an associate professor of statistics and data science at Cal Poly in San Luis Obispo, California. She primarily teaches courses in statistical computing, data science, and predictive modeling. And she's reluctantly learning to embrace a little Python in her life, but R will always be her one true love. So let me welcome Kelly.
Hello, everybody. Let me share the screen. So I think the order of these speakers has turned out interesting just because of how we all dealt with the problem you just heard a lot about of this website that seems to be very structured data that should be easy to scrape, being in fact very dynamically generated and therefore only scrapable via a, some kind of driver of a browser. Like it's not going to be possible in the sort of easy peasy shortcut scraping approaches that we may have seen before. So just to take you through my process a little bit and then show you what I landed on, I went to this website, right? I inspected this website and I saw what the other two panelists saw, which is that there's kind of a very nice boxing on these competitors, right? It's labeled as competitor container or competitor. I think there's a parent box that has the word competitor in it as well. So if I had this HTML that I'm seeing in the inspection, this would be very straightforward and my preferred package. So I like header 2 for connecting to websites, and then rvest is the package that I would use for scraping. So then that was the first thing I tried, of course, and I could show you this code, but it's all very like messy and perhaps has some swear words in the comments. That didn't work on first try, as you just saw Brandon talk about, that we can't just jump straight to that HTML. So then I, went down the rabbit hole that the other two panelists went down of, can I have a driver? I used to do this years ago in Ruby. I used to run, use Mechanize and Selenium to run headless drivers and scrape things. I don't remember how to do that now. But I did track down most of the resources I found were a package called rselenium. But I actually, based on my experience, might recommend away from that. It doesn't seem to be regularly updated these days. I did find this really beautiful package that's newer called Seleniter, so I just wanted to shout that out. It has really nice API, like very clear, straightforward functions, as well as it plays nice with rvest. It's kind of the same style as rvest for pulling HTML elements. So this is the one I liked best, but I still did not get that one to work. The reason for that being that scroll down and click the button issue that you just heard about. That was where I hit a wall, where I hit a, if this were a project that I needed to do with full completeness, I would still stick with this Olympic website because that's where all the information is much more structured and much more complete, where I have confidence in the information. So, if this were a client project, for example, I would take the time to keep troubleshooting indefinitely on the Selenium WebDriver, figure out that the reason why my button wasn't clicking was I need to scroll down physically to the bottom of the page to click it to get all the elements. So I was able to get the first 50, but where I hit a wall and decided to set some boundaries on my time and my work was at the point where the button wouldn't click because I couldn't get it to scroll down. So I guarantee you it's possible, and this is the package I would use, would be Seleniter. But I got to this point and I said, look, I need some data here. The data is the interesting part. So I just took a left turn. And I said, all of this information is on Wikipedia, right? There's Wikipedias for the Summer Olympics. So nicer to do it via the Olympic page, but the Olympic page is a pain in the butt. So Wikipedia is always easy to scrape. Let's look at it. And so what I did is I looked on this page and I found this is a general page. I found the list of all the countries. So maybe I'll show you my code now. On this 2020 Summer Olympics website, what I did is found, and this is using Here, this code here is using header 2. And then once it's pulled into header 2, I'm using rvest to identify elements. So I said, there's a lot of tables on this page. Let me find them all and let me detect the ones that talk about participating National Olympic committees. So if I want to, control F here, there we go. So this would be the list of all the countries. And so then I clicked into each country and I found that within each country, there is a complete list of athletes, although it's not all together. It's by sport. So what they have is sections here, like this would be the track and field one, the athletic section, and then all the athletes for that sport. So the approach I ended up taking was exactly that, was, for each country, I would look at the link that is available in the table on the original page, right? And then I would go into that country and I would say, I made this regular expression of all our sports of interest. And then I would say, let me find the section headers. So I'll come back to this try-catch, although I think some others have mentioned it, but I'm finding all the tables and all the section headers. So what this is giving me back, this line here, is a vector, basically, of HTML bits, kind of chunks of the HTML text. All the chunks whose tag is H2, because I noticed that was the tag on the sport, and then all the tags that are tables. So I kind of got this mixed up list that was like athletics, the H2, and then the table, and then cycling, and then the table, and then judo, and then the table, and so it was a mix and match. And the reason I did that is that I noticed that each section, this is my approach to sort of saying, find me the next table after the section header of the sport that I'm interested in. So I said, let me look at all of those ID attributes. It turns out the tables do not have ID attributes, but the headers do. And in fact, that ID attribute is exactly the name of the sport. So you can see that over here, ID equals judo, right? So what I did is I said, based on those ID attributes, let's see which ones are my sports of interest. So this is where I'm calling that regular expression. It's a very chunky, it's just literally each sport name in the way that I saw it appear in these headers. So that's, where in my list of elements of H2 and table elements, where are the headers that are the sports I care about. I use this to find, just consistently pull out the name of the sport in case it appeared slightly differently. Like in some, for the USA page, it was football parentheses soccer, right? Because we don't call it football, so things like that. But the important trick here is that I said, I'm assuming that the next element in my list after the header I'm interested in is the table I'm interested in. So let me go one index down in my list of headers and tables. And then let me go into that list and let me find the first cell and let me find the link in that cell. And so if we look at these tables of athletes, the first cell here is going to be the athlete's name. And if there's a link available for that athlete, which there's not for every athlete on Wikipedia, as we've seen, but if there's a link, then we'll see a link to the Wikipedia for that athlete. So once I find that first cell, then I say, I'm just going to throw, this is all the athletes for the sports I'm interested in. I have my text, which is just the name of the athlete. I have the href attribute, which is going to be the Wikipedia link for that athlete. And then I have whatever sport that I pulled that I'm interested in here, because in this code, and I'll come back to this, but in this code, I'm pulling all the sports I'm interested in from one country's page. So country level is the highest level. And then the name of the country as well. So that's what I'm returning for each country. So for example, for the United States, here's kind of what it looks like. And you can already see one of the problems I ran into, that the structure for some sports is a bit different than others, and also a little different by country sometimes. But overall, we're getting the name of the athlete, the sub URL to get to that athlete. So I didn't have to build these URLs from names, like Brandon just showed you, and then the sport and the country. So then now I have all this information. I want to go into each athlete's sub thingy, and I want to say, okay, in that page for each athlete. So there's one. Brandon already kind of went over this, but this is where I'm seeing the date, right? And in fact, if I inspect that, what we're seeing as humans is 7 August 2002. I cannot believe there's athletes born after the year 2000. Makes me feel very old. But in this element, oops, didn't select it very well. There we go. In this element, there's also actually like some hidden information, which is the birthday in kind of standard form. So that's what I accessed. So I said, let me go find that particular table. Let me go find the element, of this table that has the birthday information. And then similarly to what Brandon just showed you, I extracted by regular expression. I suppose I could have extracted by this span class B-day, but some of the ones I looked at didn't have that that very handy class label. So I just pulled, 4 numbers dash 2 numbers dash 2 numbers. I pulled the whole date. I thought it might be interesting to look, if I was going to expand this analysis, to look at years as well. Maybe, younger athletes being born in certain months or older athletes. I don't know. I just pulled the whole thing. A little bit of handling of like if we don't find their birthday, which was true for some of them, and then we return that athlete's birthday. So what I do then is I take that list of athletes that I had created. So here's the one for Afghanistan. And then I look at that URL column that has all of the athlete sub URLs on Wikipedia and map over all those to get the birthdays. So here's the 2 birthdays for those 2 relevant athletes from Afghanistan. So then I just put it all together in a very boring wrapper function that says, given a country, get me the country and then get all the birthdays. So I can run it, for example, for Afghanistan, and now I've got birthdays tacked on to that list of athletes. So then all I've got to do, remember, I already got the links for all the countries. I already scraped that from the main page. So now I'm mapping over all of the country links. The first one is like the header link. So that's why I'm dropping the first one. There were a lot of these where the athletes don't have their own Wikipedia page. And so they'll show up as, not clickable in these tables. So down, oops, that one was already clicked. Down here, right? This would not be a clickable link. Well, it is a clickable link, but it's a clickable link that says, hey, you could be the first one to make the Wikipedia page for this person. So that was where some of these try catches are happening. If I, attempt to access a page for a country and I can't access that page, then I'm going to print out skipping. And I didn't end up having to skip any countries. Those URLs all existed, but built that in just in case. And then for the athlete section, here we go. Yeah. If I couldn't find the URL for the athlete, then skipping. So I didn't really cleanse this output, but you can see like there's a number of athletes that I ended up skipping. And you can see that the URL that was scraped for that athlete from the country page is saying like, hey, look, you could edit this, you could make this new page. It's a red link. So bunch of athletes that got skipped because they're not on Wikipedia. So then we finally have data. Now, a few caveats. I noted this at the end of my document, but a few caveats. At this point, I had sunk so much time into trying to do the headless driver, which again, as I say, if this were a like full client project, I would have continued to pursue that because that is a cleaner approach than trying to parse the Wikipedias, as far as like being guaranteed that you'll catch all the athletes. But some stuff that was missing here. So you saw that issue when I showed you the output for the United States, which was the table for the Olympic basketball team for the United States. If we look at us, there we are. For individual sports, it lists the athlete. This is all the winners. So I skipped that. For individual sports, it'll list all the athletes, right? So here's track and field. But for the team sports, another issue with the individual sports, it lists the men and the women separately, right? And in fact, it has it subsetted by various events. So to be thorough here, if I had infinite time in my life, I would have needed to do some kind of like pull all of the tables between my desired header. So my desired header being athletics and whatever the next header is. So I need all the information in all the tables from this section, even though it's showing up in these separate tables here. So one way that I would upgrade this, again, with infinite time, is instead of my function being to look at all the relevant sports, I would have had separate functions, or at least an option in my function for each sport, so I could handle these 6 sports in different ways. So if we look at basketball, here it is, you can see that they don't list the athletes, they list the team. So in order to get the athletes, I would have to click, well, actually, I don't have to click, sorry, I thought here, the roster. So I'd have to find the table that has the roster to get all those names. And that's like a slightly different format. It's consistent across countries, but a slightly different format than the athlete lists and the individual sports. So the data at the end is not as satisfying as I would like, because I did not end up having time to upgrade to pull these correctly. But this is the approach I would have taken, although the approach I really would have taken was the Olympics.com. But for the individuals, we managed to pull most of them, so that's nice. So back to our data. Oops, spoiler alert. So cleaning up the data, I built it pretty cleanly, but I'm just using Lubridate to parse these date strings that I pulled into understanding of dates, and then to yank out the month, since that's what we were interested in. And then I just took the individual sports, because again, that's where I was able to gather the lists by way of example. And so here's the frequency of birth month, and you've seen the kind of gratifying, right, that I just saw a very similar plot. And it does look like January is a bit higher for the individual athletes. I don't know what we think of that. But then I made them by sport here. So we can see just the blue is the top 10% and the red is the bottom 10%. Not a lot of consistency, but you do have January showing up in these two, not in gymnastics, for whatever reason. But what I didn't see in the other two panelists is the statistical analysis. Like, this could happen by chance, right? So if we look at each of those individual by sport chi-square tests, just to see, tested against the null of all months are equally likely, none of them are even close to significant. So even though it looks like January is a bit higher, that is not outside the realm of, if we gathered this many athletes, some might randomly fall more on one month than another. However, if we look at the whole thing aggregated, which is a little bit of maybe data fishing, that one's close, right? That one is by some standards like suggestive. So there maybe is a little bit of evidence, even in this limited data that I was able to pull without nuancing it further, a little bit of evidence of January month for those individual sports being higher. So some comments on this. Yeah, the dynamically generated websites have been a thorn in my side for like 2 decades now, and things get better. There are better packages and functions now, but it's still such a pain. So, I'll pop some slides. I have some general slides about like web scraping in general. I'll pop them into the chat. But one of the takeaways I have in those slides is that if you can find a solution that is not, web scraping a JavaScript site, that is probably better. So actually, the first thing I did after I got stuck is I said, is there an API? So I searched for an API that already existed for Olympics.com. Didn't find one that was any good. These ones are different and hard to use. So, and then, then I said, is this data available elsewhere, which is how I found Wikipedia. So I do want to encourage people, especially if you were looking at those first 2 talks, as I sort of was, going, wow, these people are wizards. How would I even know to like do this headless WebDriver? You don't always have to scrape data if it exists somewhere already, or if someone has already done some of the work for you. So but yeah, if I was accomplishing this fully through the Wikipedia path, I probably would have done different functions for each sport. Some things I would have loved to look at. I wanted to think year of birth might be interesting. Country and gender, of course, although you run into like sample size problems with many countries having only a few athletes per sport. And maybe some athlete ranking, like what we see, kind of the motivating question came from hockey, and we're seeing athletes perform better because they are older than their peers. So a little bit of not just who makes the Olympics, but who is good, who performs well. And then lastly, and this might answer your question, Brandon, I ran these chi-squared tests for if every month is equally likely, but that's not it. That's not true. There's different rates of babies being born in different months. And this also varies by country because it correlates to holidays. So July is the most common birth month in the United States. So I wonder if that's why we're seeing high July in team sports. The United States has an emphasis on team sports and just a lot more athletes in this data set. I wonder if that's where that July that you're seeing might be coming from. Yeah, okay, so I think that's my approach. And I will pop these general web scraping slides. The last thing, and I'm sorry, I missed the first bit of the talk, so I apologize if Susan mentioned this, but the thing I didn't see mentioned is the ethics of web scraping, which is websites don't always want you to scrape them. And the way to tell is if you go to the base site and you go to robots.txt. It's like /robots.txt after any website at all will have something. And it has some of these like automated disallows. You'll see more and more these days. I couldn't find a good example, but I saw one the other day of blocking AI. So blocking like ChatGPT from scraping. And you'll find some of them that have like messages for humans. So some of it is this automated like blockers on scraping, but some of them will tell you things. So like Reddit, for example, blocks nothing. It says Reddit believes in open internet, but not misuse. So please check out our public policy. And this is where you know, it's not automatically stopping you, right? But you are responsible if you are web scraping a site to first check the robots.txt. And sometimes it'll say things about the purpose of the use of their stuff. And sometimes it'll say things like, please don't query us more than 3 times every, 10 seconds. So it'll ask for some slower queries to keep from overwhelming their servers. And so it's kind of your responsibility if you're scraping to respect that. So I wanted to point that out. Okay, I'll pop these slides link in the chat. And yeah, I think we're ready for questions.
All right, Kelly, thank you. And thank you to all the panelists. So in terms of timing, we are at our time, and this is a scheduled break. I don't see questions in the Q&A. I will follow up and say that the slides mentioned will be in the chat, and also the code will be available on the program website. So if you're interested in that. And I think without seeing any questions or Q&A, I might use this time to do a quick break. Our next panel is scheduled for 10 after, so depending on your time zone. So we have about 3 minutes.